Hello, welcome back to Mr. Mel's Maths. We are back to solving linear equations in this video. This is the fifth video in a series of videos on linear equations. Not sure how many there'll be yet, but they'll just keep coming until I think I've done everything that you need to know in order. So if you haven't watched the first four, it'd be a good place to go back and watch those and make sure you're happy with all the ideas in them, and then move on to this video afterwards, because this involves all the techniques that are covered in previous videos with some new layers added in as all kind of equations will progress in that fashion. So this video is going to involve fractions that are over a single denominator really quickly, which will just help recap a little bit of what we've done. And then we're going to look at fractions where you've got different numerical denominators, so different numbers on the bottom of the fraction, and the best way of dealing with those things. There's a couple of ways of doing this. There's some shortcuts which can lead to errors if you're not careful, but they're good if you're efficient and happy with brackets and how it works. But there'll be the full kind of method from scratch as well. So let's get stuck in. Question one is going to be over one single denominator. So the first question is 2x minus 4 all over 2 is equal to 4. Lots of 2's and 4's in this question. So when you've got this, we've done questions before when we've had fractions, numerical values, so a number on the denominator. And in order to clear this, remember fraction is like a puzzle. We're trying to balance things out. Whatever we do to one side, we've got to do the same to the other side, because if we add 5 to one side, we've got to add 5 to the other side to balance it back out. All those rules still apply. We've got our left-hand side and our right-hand side. So our left-hand side should be quite clear here, right-hand side here, big equal sign in the middle. And you've got to keep those sides separate as well. But whatever you do to one side, you do the same to the other. So in order to clear this fraction, notice both bits, the 2x and the minus 4 on the left, so these two bits, they're both all over the 2 in this question. And that means in order to kind of access the x, which I remember we're trying to get x on one side on its own as the ultimate goal, we need to get rid of that 2 on the bottom first. Fractions are ugly and we want to clear them. And we clear them by multiplying both sides by the denominator. So I'm timesing by 2 because there is this 2 on the bottom. Not the 2x, that doesn't matter, that could be 3x or 10x or a million x. The 2 on the bottom means I'm going to times up by 2 because that will cancel the division by 2 that's happening on the left. When I times the left by 2, it will just clear the division by 2, so I'm just left with the top, the numerator on this fraction. But to balance it out, I've got to times the other side by 2, so I do 4 times 2, which gives me 8. Remember, each time our equal sign should run down the page. Everything should line up. Mine just about lines up there, just to make things easier for you to see and to deal with. And then from there should be quite straightforward from the other videos. We're going to add 4 to both sides to get rid of the minus 4, which will leave us with 2x on the left, because we add 4 to get rid of the minus 4, becomes 0. And on the right, I have to add 4 to balance it. So I'll do 8 plus 4 is 12. And then to get rid of that multiplication by 2 in front of the x. So remember, 2x means they are multiplied together. I'm going to divide by 2 to cancel that multiplication. And if I divide the left by 2, I'll get x, which is what I want. But I've got to divide the right-hand side by 2 as well to balance that out. And that's question 1 done. And remember, you can always, if you've got time, sub this back in here and check that the maths works out. 2x is 2 times x, 2 times 6 would be 12, 12 minus 4 is 8, and then 8 divided by 2 is 4. Okay, question 2. We're going to look at 10 questions in this video. They're going to get increasingly more difficult as we go through. So let's do another one. Let's just change the side and make it a minus 2x. And again, different ways of dealing with this, but I will do the way that I feel is best. So again, 7 on one side, I can't really do much with that, but the right-hand side is where the x is. That's the thing we're going to manipulate and think about. So to get rid of the division by 3 on the bottom, I'm going to multiply both sides by 3. And again, like I've done in other videos recently, you might want to write the question down and pause the video at the start, have a go if you feel confident with the technique, and then you can look at my solution. Or you might want to just follow along. You can always rewrite the questions out after and have a go at them yourself. So we're going to times by 3, because this thing on the bottom, this division by 3 is happening. So if I times both sides by 3, I can put the little hints. If you're happy without the hints, that's fine. Just don't get it wrong. Keep them in because they will help you, remind you what you've done. When you get better and better, you won't need those hints, and it's clear, logical progression that you've done here. Your working is in the steps that you've written, but the hints in red are there just there to help you out for now. So times the left by 3, and when I times the right-hand side by 3, this side, it's going to clear that division by 3 on the bottom, so I'm just left with whatever lies on the top of that fraction. And then I can deal with this however I see fit. You might want to get the x's positive by adding 2x. You might be able to do it with a negative x, that's fine, but I'm going to add 2x to both sides to get the x's positive. That's what I've done in previous videos. So we'll have 21 plus 2x equals 3. Add 2x to the right to get rid of the minus 2x. Got to add it to the left as well. Then I can minus 21 from this side and minus 21 from this side to leave me with 2x. 3 minus 21 is minus 18. And to get rid of that timesing by 2 here, same as the last one, I'm going to divide both sides by 2. So divide by 2, divide by 2. So divide the left by 2, I'll just get x. When I divide the right hand side by 2, it's minus 18. 18 divided by 2 is still 9, but because it's minus 18, I just get minus 9 here. And that's how you do it when you've got one big fraction. Notice in these questions, everything is over, the whole of that is over the 3. So when I times by 3 in that first step, it just lifts the bottom. It kind of clears the fraction, we say, and I just get the numerator that's on the top. Okay, let's have a look at question 3. So let's put some different denominators in. In fact, no, this one hasn't got different denominators yet. This is just one which has slightly different setup, and we need to make sure we're happy dealing with it. So I'll run through this one quite quickly because it's the same techniques as in the previous ones. Oops, sorry. So the difference between this one is that I've got this extra, and again, if you want to write it down, have a go. I've got this extra minus 2, and how you deal with that is up to you. The quickest thing to do is probably just to add 2 to both sides to get rid of that minus 2. That plus 2, or sorry, that minus 2 is completely separate from that big fraction. Hopefully you can see quite clearly this fraction kind of ends here. And as soon as I see a positive or a negative, plus or minus sign, there's a new term. And the minus 2 is a separate term, so it's separate from that 5 plus 6x all over 3. So I can add 2 to both sides here. When I add 2 to the left, I'll just be left with a fraction. But I've got to add 2 to the right to balance things out. And hopefully we're getting used to that idea. Then we're going to multiply by 3 to get rid of the division by 3. Over 3 means divide by 3, so times by 3 will get rid of that. So I'm going to get 5 plus 6x on the left when I times by 3, but I've got to balance by timesing the right hand side by 3, so that's 30. And then minus the 5 from both sides to give me 6x equals 25, and then divide both sides by 6 to get rid of the 6 multiplying the x. Remember, we've done the lesson 4, looked at some kind of awkward values. So when I divide by 6, remember division by 6 is the most important thing here. It doesn't matter what's on the right, it's the 6x that dictates what I'm doing. So I'm going to divide both sides by 6 because of that. If it doesn't go in, all I have to do is write 25 divided by 6, which is 25 over 6. Don't write the division sign there. You're always writing fractions now when we divide. That's the best way of writing things. Can't be simplified, so that's my final answer. Yes, we could write it as 4 1/6. Or find a decimal, but the decimal will be ugly, but it's best as 25 over 6, 2 nice, neat whole numbers in an improper fraction. Okay, number 4. So 4 is 5x plus 2 over 3 equals 6. I've included this one because people often get confused with how to deal with the 2/3, and also just to show you, if you do have slightly different values, not just whole numbers like plus 2 in here, I can still use this technique that we're doing in this question to make everything whole numbers and nice integers. So when I multiply up, because I'm multiplying by something, it's going to clear the fractions, create whole numbers, which are much, much easier to deal with. Some people here like to minus 2/3. 6 minus 2/3 is going to be a bit ugly. You're going to have 5 1/3, you know, where you're going to have to convert that to 16 over 3. It's going to be ugly to deal with. If you can get things as whole numbers, it's much easier to deal with that in the question. So the first thing I'm going to do here is I'm going to times up by the 3. So again, because I've got this 3 on the bottom, yes, it's not the x term, but because I've got 3, if I times by 3, I know I'll clear that fraction, and it'll just make things a little bit nicer and easier to deal with. This is a separate term, so I have to times this by 3. The fraction times by 3 just clears the bottom. I've also got to times the other side by 3. Notice I times everything by 3, all different terms. So anything that's separated by pluses and minuses, they all get multiplied up. And then you can see I've now got nice whole numbers. I'm not dealing with 5 1/3 or some weird horrible fraction. timesing up gets us nice, easy whole numbers to deal with, and that's why I'd strongly recommend doing that as soon as you can. And then from here, should be nice and easy. We'll take away 2 from both sides to get rid of that plus 2. So 15x equals 16. And then we will divide by 15 to get rid of the multiplication by 15 on both sides. And again, 15 doesn't go into 16, so I just write 16 divided by 5, 16 over 15. Sorry, over 15, I think I said 5. Okay, and then we'll start looking at ones with different denominators. Again, if you want to write it out, have a little think, that'll be good, but this is a new question or a new style. So x plus over 2 plus x over 3 equals 10. So previously we've multiplied up by the number on the bottom, and it's cleared the fractions, made things nice and easy. But here it's a little bit more tricky because I've got 2 different denominators. Do I multiply up by the 2 or do I multiply up by the 3? How do I approach this question? And the best way to think about this is, rather than doing something to both sides at the start, is actually just to manipulate the fractions to give you the same denominators. So I'm not going to write the red hints here. But what I'm going to do is I'm going to look at the 2 denominators, which are 2 and 3. And I'm going to try and pick, I'll write the hints in red bit way out the way. So I want to pick the lowest common multiple of those denominators. Okay, the lowest common multiple, I've done a video on that. It's the smallest thing that both those numbers divide into. So the lowest common multiple of 2 and 3, hopefully you have realised the LCM quite quickly of these is 6. So I can change both these fractions to have 6 on the denominator, and then I can multiply it by 6, and that's the technique I'm going to use for these. And this holds in all kinds of questions when we've got denominators like this. So if we get them both over 6, so if I get that ready to go, so I'll have to remember it, I've decided 6 is the lowest common multiple, and that's what I'm going to get them both over. Then I can write that in all ready to go. Notice I'm not doing things to 10, I'm not doing things to both sides here, I'm just going to manipulate the left-hand side. So both of these things have the same denominator, and then I can times up by that denominator to clear everything in one go. But I can't just change denominators kind of willy-nilly. So I'm going to have to try and think about how I've changed. If I change the denominator in a fraction, what do I have to do to kind of balance that out? And the answer is if I've times the bottom by, in this case, 3, to balance that, that's okay, so long as I times the top by 3 as well. So we're creating an equivalent fraction. So 3 times x, which will give me 3x on the top. So times the bottom by 3, times the top by 3. 3x over 6, if I write it out over here, just as jotting down, the 3's would cancel. So I can go back to the x over 2 if I want. So these things are the same. They're equivalent fractions. But I'm just manipulating it into a form that I want, which is going to help me, which a lot of maths involves, or is involved in a lot of maths as you get older. And then the second one, similar kind of idea. I've times the bottom by 2 here. So I'm going to times the top by 2, 2 times x, to balance that back out. So creating an equivalent fraction, just to make my life a little bit easier. Again, if I write at the side here, that x over 3, or 2x over 6 and x over 3 are the same thing. Because 2 is common, it would cancel. So I'm creating that common denominator. And what that allows me to do is then kind of 2 things. Either I can then think, wow, I've got everything over 6. There's one number here to multiply up by and times up by 6. Or I can add the numerators because I've got the same denominator. Remember, to add fractions, if you've got the same denominator, you just add the tops. So they will add now that they've got the same denominator. They wouldn't before because 2 and 3 are different. So I'm going to times up by 6, or I'm going to add the numerators and then times up by 6. It's up to you. If you want to add the numerators first, 3x plus 2x is 5x. You get them all over 1. And then you can times both sides by 6. Now I am doing things to both sides. So I get 5x on the left and 60 on the right. And then I'm going to divide by, sorry, I should have left a gap there, shouldn't I? And then we divide by 5 to get rid of that timesing by 5. Divide by 5 on both sides to get x equals 12. Okay. If you're happy and you get to this stage, so 3x over 6, once you've decided on that 6 as the lowest common multiple, you could times up by 6 at this stage if you wanted on both sides. Because you've now got a number that is matching. 2 and 3, well, what do I times up by? Do I times up by the 2 or the 3 or both? You may as well kind of get them sorted and then do it all in one fell swoop. So if I times up by 6 here, it'll clear the 6 on the bottom of that. It'll clear the 6 on the bottom of this, separate fractions, and I'll also times this by 6. Then I can add add the left-hand side. 3x plus 2x is 5x, and then I can divide by my 5, and I'll get exactly the same answer. It's up to you how you want to think about it. There are benefits of the right-hand side. I think is probably my favourite way of doing it, but the left is better when the fractions become a little bit more complicated, especially when the numerator has more than one term in it, and you'll see in later videos, and a little bit maybe in this video, of why that's important. Number 6. Remember, if you feel like it's going a bit quick, you can always pause and stop. That's not a bad idea to try and digest what's happening. I know I can get a bit excited and go a bit too fast through things and explain several different ways of doing things. But if you want, you can always just pause it or pick a technique that you're more comfortable with. But always try and understand everything, because then if they throw something a bit different at you, you'll be able to cope with it. Okay, so 6 is 3x over 5 minus x over 2 equals 1. So same kind of idea with this one. We've got two different denominators that we're going to want to clear. We've got the 5 as this denominator, and then we've got the 2 on this one. So the way of clearing both of these is to find the lowest common multiple, LCM of 2 and 5, which hopefully you can see pretty quickly is 10. So I'm going to get both of these fractions over 10. So I'm going to rewrite this as over 10, rewrite this as over 10, and I'm not going to change the right. I'm just manipulating the left-hand side here so that I'm ready to kind of times up by the same number. You might have a little think about how this is going to work. But here, this fraction, I've times the bottom by 2. So I've got to times the top by 2. 3x times 2 is 6x. The other fraction, this one, I've times the bottom by 5. So I've got times the top by 5. 5 times x is just 5x. So we're creating an equivalent fraction. Whatever I do to the bottom, I have to do the same to the top, just to get these denominators the same, because then I can times everything by 10 here and it lifts off quite nicely. I could do the 6x minus 5x on the top, because I've got a common denominator, and do it like this, like I did on the left of my last question. And then times up by 10 both sides, so times by 10. And this is nice because it's already got the x. 1 times 10 is just 10. Or at this stage, I'm quite happy for you to say, well, actually, I want to get rid of those fractions as early as possible. And now I've got the same denominator. I'm going to times up by 10, clears this, and I'll get that, because I've got to times both sides, and then 6x minus 5x, I will get the same answer. There is a technique where you can go kind of straight from here to here, but I'm just going to leave that out for confusion for now. I might throw in a little video of that later on if you're interested. If you understand the principles and you're good with your minus signs and your brackets, you'll be able to cope with that. If not, then this method is good and it gives you that extra kind of security in doing it. Okay, sorry, random line. Number 7. So we've got 4x over 9 plus 4 equals 2x over 3. So as soon as I see these different denominators, I'm thinking I want to get a common denominator, because then I can times up by that number. And the way of getting the common denominator is to pick the lowest common multiple of those two denominators. You can always times them together. 3 times 9 is 27, that would work. But if you spot this one, the lowest common multiple is actually 9, because 3 goes into 9. So I'm not going to change the plus 4, it's just going to sit there. I'm not going to change the 9 on this one, so that fraction won't change because I picked 9, so there's no need to change that. It's this one on the right that I need to change. And again, if I've times the bottom by 3 here, I need to do the same to the top, times the top by 3 to balance it all out. Okay, now at this stage, this is probably where I would maybe multiply it by 9. You can try and get all terms on one side in the x if you want, but I think here is a good opportunity for you to be, well, I'll just times this by 9, because I know that's going to clear those fractions on both sides here. So times this by 9, which is 4x, just clears the division by 9. Times this by 9, it's a separate term, it's 36. Times this by 9 is 6x. And hopefully you've noticed that this thing is separate to the other part on the left, because of that big plus sign. Notice how the fraction doesn't go all the way over to the plus 4, it stops. Not like the first questions we looked at, where, for example, this one is all over the 3. So when I times up by 3 here, on this one, eventually, it clears that I don't times the 5 and the 6x because they're both over the 3. But here, in our most recent one, because I have got a separate plus 4, it's not that 4 here is not over the 9. It's its own term. So when I times both sides by 9, it also has to be multiplied by 9. And then from here, I can get all the x's on one side. Previous video on this, I think it's less than 3. So I can minus 4x to get all the x's on one side. Try and keep the x's positive if possible. So minus 4x on the left cancels the 4x. Minus 4x on the right gives me 2x. And I can divide by 2 on both sides to get rid of the timesing by 2. And I'll get 18 on the left, x on the right, and I can just tidy it up by writing x equals 18. 3 more questions. So number 8 is 5x minus 2 all over 3 equals 2x plus 7 over 4. The reason why I've included this one is people often use a bit of a shortcut like, oh, we'll cross multiply, and I don't think that to me that doesn't really mean anything. I don't really like the whole idea of cross multiplication. I think it confuses people. So if you just follow the process and the principles that I've laid out in this video, it will work perfectly for you. So I'm going to find common multiple of the two denominators, 3 and 4, and that number is 12. Remember, if you want to pause and think at any stage, please do, because it's good for you to figure out for yourself. So I'm going to get both fractions over 12. So I'm going to get this one over 12, and I'm going to get this one over 12. And I can get that all set up and ready to go, so I don't have to think or remember it. I pick 12, that's the number I want, so I can get that all set down in stone. Here I've times the bottom by 4, so I've got to do the same to the top, times the top by 4. What I would strongly recommend here is that because it's made up of two things, the 5x and the minus 2, it goes in a bracket, and you put a 4 on the outside. You can do 20x minus 8, but mistakes can creep in later if the question changes slightly. So I would have always put the number on the outside when you've got more than one term. So 2 terms here, they're going to both need to be multiplied by 4, and the best way of indicating that is to put a bracket round that. And the same on the other side. So I've times the bottom here by 3 this time, so I'm going to times the top by 3. I'm going to put that 2x plus 7 is the top, I'm timesing it by 3, put it in a bracket because it's made up of 2 parts. A little bit more complicated than just timesing, say, 2x by 3 here to give me 6x. That's a bit easier. That's why I didn't include the 3 times 2x. I just did it in my head. But here, there's a bit more going on, so it seems sensible to write all that in. Whatever I've done to the bottom, I do the same to the top. And now, hopefully you can see at this stage, I can just multiply everything on both sides by 12 because I have that common denominator now, common number on the bottom. It will just lift off the top of this because it cancels the division by 12, and it'll lift off the top of this because it'll cancel the division by 12. And then if you've watched other videos on expanding brackets, then you'll be able to do 4 times 5x and 4 times minus 2. So just expand this side, 6x and 21, 3 times 2x and 3 times 7. And then I've got my manipulation stage where I'm going to get all the x's on one side. Again, watch the 3rd video to help with that. So minus 6x from both sides changes this. 20x minus 6x is 14x. The number won't change, and the number won't change because I'm subtracting x's. Then I can add 8 to both sides to get rid of the minus 8. So 14x equals 29. And then to get rid of that multiplication by 14, I'm going to divide by 14. 14x, 14 times x, divide by 14 to get rid of the timesing. 14 doesn't go into 29, so I just write it as 29 over 14. Done. 2 more. Again, if it's a bit quick, pause it as you go along. So 3x minus 8 over 4 and 2x plus 1 over 5 equals 3. So same setup, different fractions, still an equation to be solved. Got to do things to both sides at some stage, but I've got a different denominator. So I'm going to get a common denominator and preferably the lowest common multiple of those denominators, which is 20. So I'm going to get this fraction over 20. I'm going to get this fraction, preferably without an arrow, for some reason it crept in, over 20. And I'm not going to do anything with the right yet because I'm just manipulating the left into the form that I want. What have I done to the bottom? Times by 5. So I'm going to do the same to the top, times it by 5. It's got two parts, so it goes in a bracket. What did I do to the bottom? Times by 4. So I'm going to do the same to the top, times both bits by 4. And now I've got the same denominator, I can multiply everything by 20 and it will just clear all those fractions up. So when I times by 20, it clears the bottom of this fraction. It clears this one. But I've just got to remember to times the right-hand side by 20 as well. And now I can expand everything, simplify and solve this as a full kind of equation. So 5 times 3x is 15x. 5 times minus 8 is minus 40. 4 times 2x is 8x. 4 times 1 is positive 4. Not doing anything to both sides there, I'm just manipulating the left. I can expand those brackets. And the same here, I can simplify. The x terms will collect, they are like terms. 15x and 8x is 23x. Minus 40 plus 4 is minus 36. And then finally I can add, this is step to both sides this time, I can add 36 to both sides to get rid of that minus 36. And I will get 96 here. And I can divide by 23. And if you're not sure if it goes in, you can always get your calculator out and check. This will be 96 over 23. Because it doesn't go in. And no factors to cancel, I don't think. You might want to double check that for me. That's question 9. And then the last one, question 10. Same kind of idea. We're going to have we'll put a negative x term in there this time. So 5 minus 2x over 7 equals 9 minus 3x minus 1 over 3. And this is where you have to be a little bit more careful. If you follow my advice, you shouldn't get anything wrong, hopefully. So, two different denominators, 7 and 3. We want to find the lowest common multiple of those two things, which is 21. So we're going to get both of these fractions over 21. The 9 is okay. The minus is just sitting in front of that fraction. So I'm going to get them both over 21. And we're creating equivalent fractions. So whatever I do to the bottom, times by 3, I'm going to do the same to the top. Whatever I do to the bottom, times by 7, I'm going to do the same to the top. And notice that negative sign, this is where problems always creep in for people. So this negative sign is at the front of everything in that fraction. This whole fraction has that negative sign in front of it. So that means everything is being made negative by that sign. So that negative sign is going to sit there. It's really important that it just sits there. When I times the top by 7, I'm going to get 7 lots of 3x minus 1. That negative sign is still going to sit there. I'm going to talk about how to deal with it later in this question. So once I've done this, I've got the same denominator. Now I've got that 21 on the bottom of both. I know if I times by 21, it's going to lift off and clear both these fractions. So I'm going to times both sides by 21. When I times the left by 21, it just clears the top. I've got to times the 9 by 21 because it is a separate entity. It's a separate term. It's not over the 21. This over 21 stops. Clearly kind of stops. So the 9 needs to be times by 21. So 21 times 9 is 189. Testing my mental maths there. And then it's just going to clear this. Now this is where the bracket is so important. Because when I have that minus sign in front of everything, when I expand this bracket, that minus sign has to be taken into account on both parts of the expansion. Lots of people don't write the 7 in. They times up by 7 and write this. So they'll times by 7 and times by 7. Leave the minus sign outside. And then they'll make a mistake because this will actually end up giving you the wrong answer. And we'll see what the right answer is going to be in a second. So I can expand brackets on both sides. So let's do that. So we're going to do 3 times 5, 15. 3 times minus 2x. Always include that sign in your calculation, so important. 3 times minus 2x is minus 6x. There's early videos on that too. The 189 is just going to sit. But this, I'm going to get minus 7 times 3x. Be careful with those brackets. And I'm going to get minus 7 times minus 1, which actually gives me plus 7. So be very careful, and that minus sign catches so many people out, because it's going to make both little bits of this the whole way through. It's going to make both of those bits negative. So that's where brackets are so important when I do this. Okay. Sorry, go to the x. Then I can simplify the right. Not doing anything to both sides here, just simplifying. 189 plus 7 is 196. And then finally I can get x's all on one side, numbers on all the other, and deal with it as we have done previously. So I'm going to add 21x to both sides to keep the x positive, to make it a bit nicer. So the 15 won't change because I'm adding x's. Minus 6 plus 21 is 15x. So add 21 to that. 21x to the minus 6x. And then when I add 21x to the right side, the 196 won't change because it's a number. It will only change with numbers. I'm adding x's here, but it will affect the minus 21x. And then from here, I can take away the 15 from both sides to remove this, which will leave me with this. Take away the 15 from this side, which is 181. And finally, to get rid of that 15 in front of the x, I can divide by 15 on both sides. When I do that, I'll get 181 over 15. And I don't think there are any common factors to that either. 5, 3 doesn't go in 15. So I think that's fully simplified. Do put in your calculator and check. I should do the same, although I'm pretty confident it won't simplify. And this shows I don't have to do, this shows I don't have to do the calculation. It's nice to write it as that. Rather than trying to find the really ugly decimal here, 181 over 15 is 12.0666, really horrible. Or trying to write it as 12 and however many 15ths that is, 12 and 1/15. It would be really ugly. Just hands off and leave it alone, job done. This is the best mathematical answer for this. So that's solving equations with fractions where we have different denominators. The next video on solving equations will involve something else, squares and square roots, and then we'll move to things like algebraic denominators and how to deal with them. If you haven't watched 1 to 4 already, watch them first. If you've got to this stage without watching them, fair play, but you will want to recap this. This is quite a bit tricky. There's a lot more steps to this now, but it's all following those same kind of underlying principles. Thank you for watching again. It's nice to see you all. Hopefully you've enjoyed the video. Please do like the video if you found it useful, and there's plenty more videos coming. Any requests, please let me know. Thank you. Have a good day. See you.